All right, good morning. It is 7:30, so we'll go ahead and get started. If you haven't done so, on your own time, do the ACT bell work. You time yourself 5 minutes, and you try to complete those in 5 minutes. 5 problems, I should say. And what we're trying to learn today is I can factor quadratics. So to be a quadratic, that means anything to the second power. So we are going to start off with only polynomials to the second degree. And eventually, we're going to go to polynomials of third degree, fourth degree, and maybe even fifth degree. And so we're going to start off, and I left off the 2. I'm actually going to fix that right now. I should say 2. So I could factor a quadratic when the first number is a 1 or a -1, and also I could factor greatest common factor. Now this should be review from Algebra 1. We use this quite a bit in this class, so the next 2 class periods are going to be review of factoring from Algebra 1, but we use it so much that I need to make sure you understand it. And so for some kids, this kind of helps. Let's see if I can figure out how to. So when we're factoring, we're trying to take a number and we are trying to break it up into smaller factors. And so, for example, if I think of the number 9, there's 9 is 1 times 9. 9 is also 3 times 3. 9 is also -3 times -3. And 9 is also -9 times -1. Okay, so what we were trying to find is a factor that multiplies 2 factors that multiply to 9, but add to -6. And so when I think of the factors of 9, what adds to -6, and that's not going to be the best one. That would be -3 and -3. So when I'm doing this, and this is very simple, just regular numbers, what multiplies to 9? -3 times -3, but adds to -6. -3 plus -3 is -6. So here, what multiplies to 4 and adds to 4 would be 2 and 2. 2 times 2 is 4. 2 plus 2 is 4. Here, what multiplies to -30 but adds to -13? That'd be -15 and 2. -15 times 2, -30. -15 plus 2, -13. So factoring is really easy if you understand your multiplication tables. If you don't, feel free to use a calculator. But we're going to go ahead and move from these just regular numbers to a quadratic with factoring. So when we're factoring quadratics, we are trying to make it such that instead of x squared, it's just an x. And eventually, we'll start with x to the 4th, and we'll take that down to x to the 3rd, and then we'll take that down to x squared, and then we'll take it down to x. So the more you break this, what we call a polynomial, down, the more we could get information from it. So today we're just going to factor. So I need to think. I need to find do it right here. I need to think of 2 numbers that multiply to 40 but adds to 14. And I'll write that, and I'm not going to write that every single time, but I'll do it today. So it's going to multiply to 40 and add to 14. So when I go through what multiplies to 40, well, 1 times 40 is 40. 2 times 20. 3 does not go into 40. 4 and 10. 5 going to 40, yeah, 5 and 8. 6, no. 7, no. And then it repeats 8, 10, 20, 40. So there's only one combination of those numbers that adds to 14. And I almost picked this one, but 8 plus 5 is 13. 10 plus 4, that would be your magical combination. So you'd put 4 and 10. Or if you put 10 and 4, same thing. And so what we're going to do is we're going to break this quadratic into what we call linear factors. Linear means to the first power. So we'll break the x into x, I'm sorry, we'll break the x squared into x and x. And then we'll just put our numbers and keep the sign. This is positive, so it'll be x plus 4, x plus 10. Okay. So we're done. We took something to the second power and we made it to 2 first powers, what we call linear factors. Now, why would we care to factor? These tell us the x-intercepts. These tell us where they cross the x-axis. And we'll talk more about this later on, but I know an x-intercept is -4, and I know an x-intercept is -10. And so that's why it's really useful to know how to factor. You could also use the quadratic formula to find the x-intercepts, but that actually takes longer in this case. Using the formula x equals -b plus or minus square root b squared minus 4ac all over 2a would spit out -4 and -10, but it's way faster to do it this way. Okay. So that's our first example. Now, if you want to check your work, you could distribute and go x times x is x squared. X times 10 is 10x. 4 times x, 4x. Add that to your 10x from before, you get 14x. And then 4 times 10 is 40. So anytime when in doubt, you could just multiply these two binomials and make sure you get the same result. Any questions so far? Remember, if you have a question, you could type it into the chat box and I will definitely stop and try to answer it. Just make sure it's a question about math is all I ask. So we just did an example where the leading coefficient was a 1, but what if the leading coefficient is a -1? Now what this negative does is it flips the graph over. So like x squared, and you don't need to know this yet, but x squared looks like this. So it kind of opens up, and -x squared opens down. And so that's what the negative does. It just flips over the parabola. Okay, you don't need to know that yet. We'll cover that again another day. But anytime there's a negative out front, just factor it out. Now, when you factor out a negative, it changes all the signs. So that's going to change that to an x squared. Change that to a -14x. And change that to a -32. It negates it. It does not change everything to negative. It changes it to the opposite sign. And then from there, and this process I'm showing you only works if the coefficient in front of x is 1. What is that, Friday? Friday, I'm going to show you what do you do when a is not 1. So I do my factor x. And I'm trying to find two numbers that multiply to negative 32 but add to negative 14. This one's going to be trickier. So I'm going to have to go through and think about this one. 32. Well, to multiply to negative 32, that could be negative 1 and 32. Remember, a negative times a positive is negative. Negative 2 goes into 32. That'd be negative 2 and positive 16. 3, 8, 10, 20. No, 3 doesn't go into 32. 4 times 8. So I could do negative 4 and 8. 5 can't. 6 times 5 is 30, so no. 7, no. And then it goes back, and it'll be, we could say negative 8 times 4. And then negative 16 times 2. And then negative 32 times 1. But now when you add these numbers, you would get 31. Those two would be 14. Those two would be 4. Those two would be negative 4. Those two would be negative 14. And that would be negative 31. So which one did I get negative 14? Well, this one. So my magical numbers that make this work is negative 16 and 2. So let's see what I have. I have x minus 16 and I have x plus 2 and furthermore, I need to make sure that I remember to let to identify that this parabola is flipped over. So I need to make sure that negative sign is still there. So what does that mean for x-intercepts? We know by looking at this that the x-intercept is 16 and the x-intercept is negative 2. Again, we'll make sure we cover that another day. Okay, any questions so far? So another review from factoring is something called the greatest common factor. And so sometimes kids are kind of confused on what it means to be a greatest common factor. Greatest means the biggest. Common means they have that in common. And then factor would be a number that divides into those numbers. So like when I look at 7n squared minus 21, I look at the terms, and for some students, they like when I factor it out. So if I say 7 is 7 times 1, and n squared is n times n, and then I think of 21 is 7 times 3, and you do not have to do it this way. I'm just kind of showing it as breaking down the factors. For some kids, this helps them a lot. So I have two terms. I have 7n squared, I have 21. And so I'm looking for things they have in common. In common, I notice they both have a 7. I look for more that they have in common. Technically, they will always have 1 in common because 1 divides into anything. So we ignore the 1. Do they have an n in common? No. Do they have a 3 in common? No. And so 7 is what they have as a common factor, and it's also the greatest common factor. So all that 7n squared and 21 have together is a 7. So if I divide 7n squared by 7 and I divide 21 by 7, I get 1n squared minus 3. If you could look at this and go, the greatest common factor is 7. And when you divide 7 by 7, you get 1. And when you divide 21 by 7, you get 3. You don't have to do this step unless you really need it. I understand it's Algebra 2, and most of you could go from this step to this step. But I will show the work for now because it helps with kids learning. And then I will teach you how to factor this. You don't know how to factor that yet. It factors into n plus square root of 3, n minus square root of 3. But we're not ready for that quite yet. Okay, so here's another example. So I look at this, and I may not write down the factor tree this time. I notice that they all don't have x's. So x cannot be a common factor. And then I look at the smallest number. I have 7, 14, 56. I mean, 14 cannot go into 7. So anything, the smallest number is the only number you can work with. So I think of 7. The only thing that goes into 7 is 1 and 7. So 7 is what we call a prime number. So the only possibility that this could have as a common factor would be 7. 7 goes into 7. 7 times 2 is 14. 7 times 8 is 56. So I'm going to factor out a 7. And this is a case where I think it's actually easier if you just think about it. So if I factor out a 7, 14 divided by 7 is 2. And 56 divided by 7 is 8. So all I did was I took 7x squared minus 14x minus 56. Okay, and the 7, in case you're curious what happens, it takes your quadratic and it squeezes it. And we'll cover that later. So now, notice that I have a 1 here, and it's a quadratic, and there's 3 terms. So now I could do the factor x. So now I need to find 2 numbers that multiply to -8, but add to -2. So multiplying to -8, 1 times -8, 2 times -4, 3 doesn't, 4, 4 times -2, and also 8 times -1. So if I add those real fast, I get -7, -2, 2, and 7. So which one is -2? This one. So those are my factors. So I'm going to put 2 and -4. And once again, if you put -4 here and +2 here, it makes no difference. So now I could break this quadratic into linear factors. So it'd be x with the 2, x with the -4, and then don't forget about that 7. There I go. This is what we call factored form. Some textbooks call this intercept form. Intercept because they tell us the intercept's really fast. -2, +4. And again, you don't have to do that part yet. Now, I want to, on this last problem, check our work. So let's check our work, okay? How do you check your work? Well, you have 3 terms. You're going to multiply all 3 together. You're going to take either 7 times x plus 2, see what you get, multiply it by x minus 4, or you can multiply these 2 first, and then you use the scale factor of 7. I think it's easier to do these 2 first. But to each his own. So when I factor, or I should say distribute, we're going the other way now. So I would go, and I'm going to rewrite this. In case you're confused, this is where I want you to stop. I am only checking my answer right now. So checking my answer, I'd go x times x, x squared, x times -4, -4x, 2 times x, and then 2 times -4. Combine like terms. These 2 are like terms. Now we're not done. I also need to multiply by 7. Okay, 7's easy. I just multiply everything by 7. 7 times x squared. 7 times 2x, 14x. And then 7 times 8, 56. So I just confirmed that if you take 7x plus 2x minus 4, you get 7x squared minus 14x minus 56, which is what we started with. Okay, this is what we call standard form. In standard form, all it really tells us is the y-intercept. So this tells us our x-intercepts. This one tells us our y-intercept, and the y-intercept is actually -56. Okay? So standard form doesn't tell us as much as intercept form. There's another form called vertex form, and we'll cover that another day. But for today, standard form to intercept form. Standard form to factored form. Those mean the same thing. So I hope I have prepared you. If not, I walk through other examples out on my page. We could look at the practice together real fast. Looks like I have 2 people. I need to grade their assignment. So notice 1 through 9 are all quadratics. That means to the second power. Number 7 has a y. So instead of x, you just put a y. No biggie. Notice some are positive, like this is positive 1x squared, positive 1x squared. Number 3 is negative 1x squared. If there is a negative, make sure you factor it out. Can you do number 2 on the sheet? This one? Yeah. I think I have time. And then 10, 11, 12, 13, 14, 15, find the GCF and then factor it, along with 16, 17, 18. And so that's the practice. And so I've been asked to do number 2 real fast. If I could figure out how to do it on here. Let's see. Okay. Let's do this. I'm going to freehand it. Okay. So I am looking for 2 numbers that multiply to 42 but add the 13. So we have 1 and 42. This is not very easy to use this. And then 2 and 21. 3 and 14. And I'm adding these as I go because I'm going to stop. Like that'd be 11, that'd be 23, that'd be 43. So we're not there yet. 4, 10.5 times 4. We're not going to use decimals. 5 doesn't. 42 divided by 6 is 7. There it is. 6 plus 7 is 13. So I would go x plus 6. This looks like a kindergartner's writing it. X plus 6 and x plus 7. So 6 goes here, 7 goes here. Does that help? So there, I did one of your practice problems with you. Okay. Any other questions before we sign off? We do have 2 minutes. All right. Well, feel free to sign off. I will be signing into the office hours. And okay. So I was reading in the chat that the order of this matters. So like 42 needs to go on top, 13 on bottom, and that's why the person needed this. But anyway, I will be signing off. And if you have any more questions, need any more help, sign into the office hours and I'll be there. Have a nice day. Nice seeing you all. Bye-bye.